Welcome to Let Us Start Educational Channel. This channel is for teaching IIT Physics Foundation classes for class 6 to class 9 students. So, in our last class, we discussed that dimensional formulas of different physical quantities. Today we learn about what is the significance of dimensional formula and what is the principle of homogeneity. Before going to know about the principle of homogeneity and significance of dimensional formula, let us know there are two quantities in physics. One is variables, other one is constants. In variables, two types of variables. One is dimensional variable. In last class, we discussed the different physical quantities and their dimensional formulas. The physical quantities which have dimensions are called dimensional variables. Suppose that, for example, velocity, acceleration, force, work. Any physical quantity that have dimensions are called dimensional variables. So, velocity, acceleration, force and work. These are all dimensional variables. Next one is dimensionless variables. Dimensionless variables. Some physical quantities are there. They are the ratio of same physical quantity. So, they are dimensionless. Suppose that strain is there. Strain is the ratio of same physical quantity. So, both are cancelled and this is dimensionless quantity. Even though it is a physical quantity, it is dimensionless. Other one is angle. Angle is equal to arc by radius. It is also the ratio of same physical quantity. So, it is also dimensionless. Like this, specific gravity. Specific gravity is also the ratio of density. Density of two substances. So, it is also dimensionless quantity. Next one is dimensional constants. Dimensional constants. Constants, two types. Dimensional constants. In last session, we discussed about dimension formulas of different equations. F is equal to g m1 m2 by r square. Here g is the universal gravitational constant. The value of this is 6.67 into 10 power minus 11 Newton meter square by kg square. even though it has constant value, it has dimensions, so it has fixed value. Next one is velocity of light. What is the value of velocity of light? C is equal to 3 into 10 power 8 meter per second. It is also constant. It has units meter per second. So this is dimensional constant. C is dimensional constant. Like these different constants or dimensional constants are there in physics. Next one is dimensionless constants. Suppose that in the relation T is equal to 2 pi L by G. 2 and pi have the fixed value. Value of pi is 3.14. So this is dimensionless constants. 2, pi, 3, whatever it may be the numerical value, that is dimensionless constant. So till now we discussed that in physics two quantities are there. One is constants, another one is variables. This is dimensional variables and non-dimensional variables and dimensional constants, non-dimensional constant. Explanation for all these is given here. Next one is importance of dimensional equations. What is the importance of dimensional formula for writing equations? So we can check the accuracy of the given physical equation by using dimensional formula. We can check the accuracy of the given physical equation and we can derive the correct relationship between different physical quantities. It depends on the principle of homogeneity. What is principle of homogeneity? The principle of homogeneity is according to which the dimensions of all the terms on the two sides of an equation must be the same. What does it mean? One equation is there. Suppose that V is equal to U plus AT. In this equation, according to the principle of homogeneity, dimensions of LHS is equal to the dimensions of RHS. Let us check this. Dimensions of V is, V means velocity, final velocity. U means initial velocity. Dimension formula of velocity is LT inverse. Dimension formula of initial velocity is also LT power minus 1. So dimension formula of AT is A is LT power minus 2 per acceleration. T for time, LT inverse. Here LT inverse U plus AT is equal to LT inverse plus LT inverse. So LHS is equal to RHS. Is this dimensionally equal or not? Yes, here LHS of the equation is equal to RHS. Here I can add the dimension formula of velocity. Here also dimension formula of velocity. Here also dimension formula of velocity. We can add only or subtract only same physical quantities. We can't add or we can't subtract dimension formulas of different physical quantities. Suppose that here we can't keep m, that is not correct. We can add only velocity to velocity, product of velocity. We can't add the velocity to the mass of the object, that is wrong. So principle of homogeneity is the dimension of all the terms on the two sides of an equation must be the same. So this is the principle of homogeneity. By using this principle of homogeneity, we can check the given equation is correct or not. Let us check the given equation is correct or not. So one equation is given here. T is equal to 2 pi root L by G. If the equation is correct, LHS of the equation is equal to RHS. So what is LHS of the equation? LHS, T is time, so its dimensional formula is T. Next one is RHS L by G. What is the dimensional formula of L for length? So capital L. G means acceleration due to gravity, that is L T power minus 2. So that is T square. L by G is T square. Root L by G is equal to root T square, that is C, that is equal to RHS. So this is just an equation. To check the accuracy of relation T is equal to 2 pi root L by G for a simple pendulum. T is time, L is length of the pendulum, G is acceleration due to gravity. So we can derive this equation here. One simple pendulum is there. Length of this is L. Mass of this bob is M. And when it is stretched, it goes like this. And its gravity is acting in downward direction, that is G. So time period of this simple pendulum is T. T is equal to 2 pi root L by G. This is the equation. Just now derive this equation. Here LHS is equal to RHS. But one thing is, here the constant value 2 pi is there. Drawback in the writing dimensional formula is we can't derive the value of this constant. We must only know this value by the experiments only. So this is the drawback of the writing dimensional formulas. What is the drawback of writing dimensional formula? by using the dimension formula we can't identify the constant values. So this is the equation. T is equal to 2 pi root L by G. Another one is so if the relation T is equal to 4 by root L by G also dimensionally correct but numerically wrong. This value we can get only by using experiment. Next one is checking the relation S is equal to ut plus half at square. S is the distance covered in t seconds. U is initial velocity and A is acceleration. Let us find out this equation is correct or not. Equation is S is equal to ut plus half a t square. Just now we discussed that we can't get the values of constants by using this homogeneity principle or writing dimensional formulas. Here LHS is equal to RHS we can prove. So S is distance, its dimension formula is L, that is LHS. Now we can prove ut is L and at square is L. U means velocity, LT inverse, T means time, that is L, that is equal to LHS. Next one is A t square, A per acceleration LT power minus 2 t square, so that is RHS. Here LHS is equal to RHS. This equation is equal, but one thing is you can't find out the values of these constants. So another equation is given here. A bus travels a distance x1 when acceleration from rest at constant rate a1 for some time, and after that travels a distance x2 when it accelerates at a constant rate a2 to come to rest. Student established a relation x1 plus x2 is equal to a1 a2 t square by 2a1 plus a2. Let us check this equation, is it correct or not? How can you check this equation? By using the homogeneity of dimensional formula. So here bus starts from rest, starts from here, and it travels a distance x1 with acceleration a1. After the time goes on, it decelerates. That means its acceleration decreases. I will say distance x2. Acceleration is a2. So the equation is x1 plus x2 is equal to a1 a2 t square by 2 a1 plus a2. This is the equation given by the student. x1 plus x2 is equal to a1 a2 t square by 2 a1 plus a2. So here x is the distance, x is the distance. So its dimensional formula is x1 plus x2 is L plus L. So LHS is L. Next thing is the equation is x1 plus x2 is equal to a1 a2 t square by 2 a1 plus a2. So x1 plus 2 is L. Next a1 a2 t square by, we left this a1 plus a2. So is acceleration L t power minus 2 L t power minus 2 t square by t power minus 2 plus L t power minus 2. So t square cancelled, remaining is L square t power minus 2 by L t power minus 2. T power minus 2 cancel 2 okay. So LHS is equal to here x1 plus x2 dimensional formula is